Hello class 7. By now you have understood that sound is a form of longitudinal wave and that sound moves from the source to the ears of the listener through the molecules of air or any other medium for that matter when the air molecules or the molecules of the medium vibrate. Now these vibrations, as the energy makes the molecules to vibrate, this energy makes the molecules vibrate, and when the molecules vibrate in such a way that they are away from each other, the distance of the molecules are little further away from each other, that region of molecules known as rarefactions. And that region of molecule, like this and this region and this region where the molecules are closer together, these regions are known as regions of compression. Compression because the molecules are very closely packed to each other. So it is a series of compressions and rarefactions which move forward, and when it reaches to the ears of the listener, then the eardrum present in the ear starts to vibrate and the person listens to the sound produced. This same diagram also I have drawn here in my copy. You can see the region where the molecules are spread apart, that region known as rarefaction, and that region of molecules where the molecules are closer together known as compression. This longitudinal waveform can be drawn in the form of a graph in x and y axis, as I have drawn over here. Now as you can see, the horizontal line represents the x-axis of the bar graph, the graph. The horizontal region represents the x-axis of the graph, and the vertical region is divided into two parts: the positive y-axis, the upper one. This is the origin, point of origin, and this is the negative y-axis, down one. So our compressions are the topmost part of this graph, whereas rarefactions are the bottom regions of the graph. So this is the waveform that you will get. So this wave, as in this actual wave where the regions are divided into regions of compressions and rarefactions. Compressions are represented in the graph by the topmost part and the rarefactions the bottommost part. And it is a series of compressions and rarefactions. And in this particular graph, the upper part is the crest and the down part is the trough. Alright. So when we move forward towards our next topic, characteristics of sound, where you can find pitch and loudness, we will need this knowledge of waveform. So here it is, amplitude and frequency. These are the two characteristics of sound. So first thing we need to know what is amplitude. Let's come back to our wave. This is also given in your book. As you have seen that in that graph, this is the waveform by the region of compression and rarefaction. Upper one compression, down one rarefaction. Amplitude is this is our mean position, okay, from the position of the origin that I had showed you in the graph. From this mean position, how far up or how far down does the wave go? That is called amplitude. It is represented in your book as small letter a, okay. And remember, one wave is one crest and one trough. So between crest to crest and between trough to trough, the distance is the same, and this distance is represented by the Greek letter lambda. Same thing, from trough to trough, the distance is represented by the Greek letter lambda. And surprisingly, both these distances are same for one particular wave. And how to measure one wave? Here, from the origin, when the wave goes up and when it comes down and returns back to origin, that is one wave. So from here, from this position, its starting position, one crest, one trough is one wave. Then for the next wave, again another crest, another trough will be the next wave. And each wave is represented by this symbol called wavelength. It is represented by the Greek letter lambda. This is how lambda looks. Alright. So in one wave, the amplitude will be same. That is, for crest also, how much it goes from the mean position top and from the mean position bottom for trough will be the same distance for one wave. For the next wave, it might keep on decreasing because the energy keeps on decreasing. So the amount of vibrations of the wave up and down may also keep on decreasing as the wave moves forward. But for one wave, that's why it's given over here, for one crest and one trough, the amount of distance, that is amplitude, is same. So what is amplitude? Is the measure of how big the wave is. Now big wave means how from the mean position, how much it goes on top and how much it goes at the bottom for one particular wave. Okay. So from here we came to learn amplitude and wavelength. Okay, amplitude and wavelength. So in my diagram also, from here to here, this from mean position from here, that is the bottommost position of the graph, and from here to here, that is from the mean position to the topmost position of the graph, will be same, and that distance is called amplitude. So the maximum displacement or movement of the wave from the mean position either at the bottom or at the top is called amplitude. And the bigger the distance or the amplitude, louder will be the sound. So loudness of the sound depends on amplitude. Now you can see over here, just below this particular diagram, you have this. Now this is one wave of one particular sound. This is another wave. Now this wave is a smaller amplitude wave. This wave is a larger amplitude wave. As you can see, the distance from the mean position for this particular wave is small. Only till here, this much small distance as compared to this one. This has a larger distance. From the mean position, the topmost part, and the mean position, the bottommost part, is bigger compared to this particular wave. So amplitude for this wave is small, amplitude for this wave is big. So this is a louder sound wave compared to this. Now if there is another wave whose amplitude will be even bigger than this, then that will be even louder than this particular sound. So loudness depends on amplitude of the wave. Next characteristic of sound is frequency of sound. Now to understand frequency of sound, I have given over here two graphs representing two sound waves. Now as you can see, for this particular sound wave, from here to here, you have one wave. In this one wave, you have one crest and one trough, one region of highest position from the mean position, and one region of lowest position from the mean position. So one crest plus one trough equals to one wave. Now for the same distance from here to here, in this particular diagram, I have drawn two waves. From here to here one, here to here one. One crest, one trough is one wave. Again another crest and another trough is another wave. So here two crests plus two troughs equals to two waves. Okay. For the same distance, here one wave only, and for the same distance from here to here, two waves. So frequency depends on how many waves are produced in a given distance. Okay, for a given amount of distance, how many waves are produced? If more number of waves are produced for a given amount of distance, then the frequency of sound wave is more. That means this particular sound wave produces more frequency compared to this particular sound wave. Okay, if there is another sound wave which can produce from here to here 4 waves instead of 2 waves, then that particular sound wave's frequency will be more than this particular sound wave. So as you can see over here, this particular wave has 2 wavelengths. 2 wavelengths, the amount of distance that they have in this particular wave, these 2 wavelengths, when you add up, you get one of that wavelength. This wavelength's distance, we have 2 wavelengths over here. Okay, from here to here one wavelength, from here to here another wavelength. So from this frequency of sound comes the next behavior of sound, that is pitch. Greater the frequency of sound, higher is the pitch of the sound. Lower is the frequency of sound, lower pitch sound will be produced by that particular sound wave.